All right, here's the second video in 8.3. Now, this is just like the sequence in arithmetic sequences that you learned about. So in your first part of finding the nth term formula, you were given the first term and you were given the ratio. Now, just like last section, the next step was you're given the common difference and just one term in your sequence. Here, you're given the common ratio and one term that is not the first term. So we have to do the same number of steps as we did last time. We have to first find A1, which is our first term. And at that point, we will know our ratio and we will know our first term. Then we'll be able to plug them in for our formula. So, same steps. What we have to do is first use the term that we do know to find out what our first term is. So let's do that first. Now, I'm not going to have you guys worrying about graphing the first 6 terms. So I'm just going to focus on writing the rule for the nth term. So remember, let's start with figuring out what our first term is going to be. So we're going to use our general rule, and we're going to use this information right here to figure out what our first term is. So let's first go down, use the general rule. We're going to write that out. And now we know our fourth term. So let's plug in what we know. We know what r is, and we know our fourth term. So if we replace a to the n with this a to the fourth value, and then we're still trying to figure out what a1 is, but we know our ratio, and we know that for our fourth term, n will equal 4. Let's go ahead and replace all that information. So we're going to put a4 equals a1 times r to the 4 minus 1. Now look at this. We know 2. We know a to the fourth, a4. Let's replace those. We get 12 equals, our common ratio is 2, 4 minus 1 is 3. Now, we just multiply this out. We get 2 to the third is 8. 12 divided by 8 is just 1.5. So for A1, we get 1.5. So that means our first term in this sequence is 1.5. Now, for writing out our nth term formula, we know that our first term is 1.5, our r value is 2, so we're going to write our general rule down, and we're just going to replace A1 with 1.5 and replace r with 2. Let's go ahead and substitute for these right here. That's all we do right here. That is literally it. We go through the same steps as we went through before. We use A4 and 12 to figure out what our first term is, and then just plug our first term in and the ratio that we know to get our general rule. It's really, really simple. So what I'm going to do before I give you guys the problem that I want you to do, let's go ahead and I want you to solve this problem here. So you know that one term in the sequence is A5. You know A5 is 32, and the common ratio is 2 over 3. I'm going to go ahead and give you guys a minute to go ahead and solve this problem right now. Just write your problem, use good formatting, go ahead and write it in the text box, and go ahead and do that right now. All right, now that we're back here, let's go ahead and remember our third type of problem is when we only know 2 points. So here all we know is that the second term is 12 and the fifth term is negative 768. Now you can tell we're going from the second term to the fifth term. These numbers are pretty far apart. Again, remember, these are exponentially growing. So we're going to either get really big really fast or really little really fast. So this was our third type of problem with arithmetic sequences as well. We only knew 2 numbers in our sequence, but we didn't know what the first one was, and we didn't know what our ratio was. So let's use these numbers to find our ratio. So we're going to write a system of equations. So remember, this is our general rule, and we're going to substitute our second term and our fifth term into these two equations, and this is going to allow us to solve for A1, and we're going to get that value to go ahead and eventually solve for R and A1. So let's go ahead and make two equations. We know that when we have n equals to 2, we're going to get A2 equals A1 times R to the 2 minus 1. A5 is going to be equal to A1 times R to the 5 minus 1. Now let's go ahead and replace A2 and A5 with the numbers we know, and let's go ahead and work out these variables, or these exponents. So in this first one, we get 12 equals A1 times R. In our second, we get negative 768 equals A1 times R to the fourth. Now you'll see right here, we've got two variables, A1 and R, and two equations. So this is our system right now. Again, remember, in our arithmetic, we had the same types of problems. We had to make two equations with two variables to solve. Now, in arithmetic, we were just able to always subtract our equations because A1 was always by itself and had a coefficient of 1. So we were always able to subtract. Now, with these, we have to go ahead and, depending on what your exponents are, it might, be a little different. So you have to kind of look at your system and figure out which way would be best. Now, what we're going to do here is we're going to use substitution. So we're going to use our first equation, and we're going to isolate A1. So here we just divide both sides by R, and we get A1 is equal to 12 over R. Okay, so we've isolated this. Now, since we have A1, we can substitute this into our second equation. So we're replacing A1 here with this value that we just solved for in our first equation. So we got A1 equals 12 over R. Let's substitute in our second equation. Now you're going to see these R's cancel out right here. So we're going to get R cubed. So we get 12R cubed equals negative 768. Let's go ahead and work through this. We divide both sides by 12. And then we divide both sides by 12, take the cube root of that, and we get negative 4 equals R. Fantastic. At this point, I'm not going to work out each step in this because you guys know how to solve a equation with exponents. You just divide both sides by 12, you get negative 64, take the cube root, and you get negative 4. Now we know our R value. Let's go ahead and go back up here to get A1. So we can go into this equation, and we get that we plug 4 in, we get 12 equals A1 times negative 4, right from this equation here. We go ahead and solve that, and we get negative 3 equals A1. Again, we just went back to one of our original equations up here, and we put negative 4 in for R, divided by negative 4, and we got A1 equals negative 3. So now look, we have R, which is negative 4. We have A1, which is negative 3. Let's go ahead and write our equation. We're just going to substitute it back into our old equation, our general rule. So we get A sub n equals A1 times R to the n minus 1. Now that we know R and we know A1, we just substitute it, and we get A sub n equals negative 3 times negative 4 to the n minus 1 power. Very simple right here. You're just going through each problem step by step. As we start to know less and less about our sequence, we just have to do a couple extra steps, just like our sequence of steps with arithmetic. So the types of problems we're going to have are, we're going to know A1 and we're going to know R. Those are the easiest. We just plug into our equations. If we only know R and we know a different point in our equation, we're going to have to solve for A1 then get our rule. This last type of problem, we're just going to know two terms in our series. We're going to have to make a system of equations, solve for r, plug r back in to get a1, then write our equation with a1 and r. Exact same steps as arithmetic sequences, it's just that our general rule looks a little different. All right, good. What I want you guys to do now is I've got a problem for you to look at here. I want you to do number 6 right here. Don't worry about 5 right now. Don't worry about 5. Just do number 6. All you know is the second term and the fourth term. I want you to write a rule, write an nth term rule. Don't worry about graphing the first six terms. Just do number 6, write out your nth term rule.